Now, at some institutions, programming languages course just teaches you a lot of superficial syntax of a number of different programming languages that are really very similar to each other, which is why they can get away with it. We try not to do that here. The course does come in several flavors depending on who is teaching it, but all of them have this in common. There's a lot of math involved, Greek letters and shit. It's going into some actual. The point is to try to help you to understand how research in the area of programming languages is done, as well as picking up some interesting languages that you might use in future projects. So I'm teaching it in the winter. I'm going to show you the kinds of things that I do. So the weighting is like weekly assignments done on Marmoset, if you're familiar with Marmoset, for about 25%, and then the exams are worth about 75%. We go over a number of functional programming languages, Scheme or Racket as it's now known, PLT Scheme, which you may have used in CS 135. So pretty quickly, because most of you will have taken it by this point, some version of the language ML. In the past, we've used SML, Standard ML of New Jersey, but I might put in OCaml this time because it looks better on your resumes. Haskell, which is a gorgeous language and much fun to work with. And I thought of introducing some version of Smalltalk, either Squeak or the recent fork of it, which is called Pharaoh, but I have to see how that goes. As far as the theory part goes, a lot of lambda calculus, and trying to figure out how to specify the meaning of a programming language, a meaning that's something more than what happens when I run this on a machine. And the semantics we're going to use for a lot of this is reduction semantics, where the program is gradually rewritten until it gets down to a form where its meaning is obvious. If you've gone through CS 135, you'll know reduction semantics because it's what the stepper does, and you've had to do it on assignments. And some type theory. What are types? How can we prove things about types in programs? Well, all of this is quite interesting as far as I'm concerned. Now, other instructors do it slightly differently. So Brad Lushman taught the course for several years as a grad student. He is now back as a lecturer and an advisor, and he may teach it in future. I don't know. Under he has a set of notes that go with it. He does things slightly differently. This is actually wrong. I should have fixed this. He does talk about Scheme and ML and Haskell instead of Smalltalk, which was my cut and paste error. He talks also about Prolog, which is a logic programming language, and about Eiffel. And he covers many of the same things that I cover as well. His course is I based my version of the course on his and then started making changes. There is another instructor who does things a little bit differently, David Toman, who's been teaching it in alternate years. So he taught it in winter 11 and will probably teach it in winter 13. Everything's very uncertain in the future. None of our teaching assignments are set for that year yet. And he had only 2 assignments worth 20%, bigger assignments, but still only 2 of them. And midterm and final were 80%. He focused more on what are called classic denotational semantics, which work better for imperative languages such as C++ or Java. If you have such a language, then you know that a program has a tree structure, and you can assign a meaning to a program by assigning a meaning to the leaves, the tiniest pieces of the program, and then composing those meanings in a sensible way as you go up the tree. And he works out the details of this. It's a more classical way of doing programming languages. He does cover the programming language ML, in addition to a toy language that he works through the denotation semantics of, and the logic programming language Prolog as well. So all of these versions of CS 442 have what I would call a moderate workload. They're not trivial courses, but they're not killer courses. Steady workload. This is one that has a heavy workload, and I'm sure you know about compilers. Typically taught by either Andre Lotak, Gord Cormack, or one of their graduate students, one of their PhD students. In close supervision by these two, it's generally quite a good course. You're writing a compiler, so it's like CS 241 on steroids. Instead of using, you have to write all your own tools, and people really get into it. It's a lot of fun, and it has a reputation, which I think is a little bit undeserved, because it is possible to get through this course without spending your entire life on it. What happens is 2 things. 1, people are not prepared. They don't do things except at the last minute, and then they go crazy. And 2, people like it, so they really voluntarily spend their entire life on it, as opposed to it being forced on them. There is a midterm and there is a final as well. And about all I can say about this course is it's definitely worth taking, but you have to be prepared for the work and be prepared in advance. Get a good team together and don't do silly things like say, oh, I always wanted to learn Haskell. I think I'll write my compiler in Haskell. Don't do things like that. Write your compiler in something you're familiar with, because you're going to be spending enough time on the compiler itself. You don't want to be wrestling with details of what you're learning outside that. OK, and I've been asked to talk about CS492, the social implications of computing, which is a very different sort of course from the other two. And I did teach it a decade or so ago several times. I have not taught it lately. But I understand that the course hasn't changed that much since I've taught it. So in fact, if you go to the web page, there's a set of useful links that have my name on them. And I can't imagine they're still useful. They're probably a decade out of date. So Robin Cohen has taught it several times in recent years. I don't know that she'll be doing it in the near future. I've been told that Ed Lank and Michael Terry, the HCI instructors, are also, sorry, interested in it. Am I wrong? Sorry?
Longer term.
Okay. Anyway, I don't know who is teaching it in the near future. As currently taught, there are no exams, so it is quite different. There is a heavy reading component, a heavy writing component, which is unusual in CS courses. It's not so much a lecture format, but a discussion format, so the readings are done in advance, and then class participation is important. And there are actually role-playing exercises, which are a little bit like debates, except the goal is not to win rhetorical points, but to actually simulate a real-world situation and come to some sort of compromise among differing points of view, as opposed to just sort of slamming at each other. So all of this stuff is really valuable, and the subject material really is very timely in this day and age when we have things like WikiLeaks and Google collecting data on us and Facebook and so forth. So it's a course that I think highly of. And as with the other courses, I have to caution you, it might look soft. And technically, it is soft in the sense that there's not a lot of math content or a lot of technical CS content in it. But you're deploying the knowledge that you've gained in your other courses to good effect in understanding how it affects the rest of society. I think it's a very valuable course. You shouldn't underestimate it. It is a moderate workload. It's not a light workload, I would say. And for those who do take it, I think they really, I've had students come back years later and say, this stuff it still sticks in my head and it's still useful every day. So I think that's it as far as what I have to talk about.